All right, who's here at VMworld for your first time? I always like to know this. Look at
that's fantastic.
that is fantastic. Wow, that was like 3/4 of the room.
Yes.
That's
all
amazing.
Thank you
welcome.
all for coming.
Welcome.
Yes, welcome to the show. Thank you all for coming. It's very surreal for us to be up here. And we've been doing this for a long time. I virtualized my first copy of SQL Server in November of 1999. Yes, I'm a glutton for punishment. I had everything in production virtualized in 2004. It was 2006 when somebody told me, you can't virtualize that.
7 years later. You can't do that.
And we just happened to be sitting at a very large performing arts center that I did all the IT work for, including all database, virtualization, everything. And I told them, look around. Everything here, sound, lighting, data, ticket management, barcode scanners by the door, wireless systems, everything. It's all virtual. This was 2004 at the time when I did it all. And I looked at the guy and said, why can't you do this? And over time, we really realized that you can do this, you should do this, but it's not all created equal. And a lot of the things that we had to do back then to make this stuff work, you don't have to do today, but you still have to take a lot of care to virtualize these things properly. And arguably, we're also database folks. The database side of things will crush a normal system, just flat out crush it. I mean, how many of you have to fight that day in, day out? Exactly.
This is for you.
Cool. So what we're here to do is to walk you through the really big challenges with virtualizing these very large database platforms. And we're going to show you all the tips and tricks. And we're consultants. We do this for a living, and you're getting all this for free just for being here. These are the things that you need to do to make these systems run as fast as they possibly can. And it's going to make the business happy, it's going to make the database people happy, it's going to make the users happy. And at the end of the day, your life gets easier because you know this stuff is just going to work. So this is performance tuning and monitoring for virtual database servers. Standard legalese applies. I'm sure you've all seen this 1,000
I'm going to add something to this disclaimer because we're in Europe. So just in case you haven't figured it out, we speak American. So that usually means things are fast and we say words and idioms that maybe you're not familiar with. If you don't understand something we've said, please don't be bashful. Raise your hand, make us repeat it until you understand what we're saying. Okay? Good.
Or throw something at us.
Yeah. We don't speak English, we speak American.
Cool. In case you didn't know, there are a lot of virtualizing business critical application sessions at this show. There's a lot. We actually did, or I did the SQL Server on VMware Bootcamp at VMworld US a couple weeks ago. We're actively trying to get those here. Stay tuned. I don't know what's going to happen, but we're trying. They've got evidence and proof that a lot of these big mission critical systems really have been virtualized successfully, and a lot of people are doing it. Challenge is doing it right, and that's why we're here. What can we learn? Business Critical App homepage, they keep moving it, so we keep having to change the slide. Yeah. So this is the updated link. A lot of collaborative surveys between database trends. Oops. Between database trends. There's my blog, davidklee.net. There's Tom's blog at thomaslarocque.com. There's the VMware blog. Everything STDC in the VMware IOUG special user group. So if you deal with Oracle, how many of you have to deal with Oracle? I'm so sorry. But if you deal with Oracle, go to that site. Okay.
Sure. So we make a few assumptions about why you're here. First, we're guessing that you have database servers that are problematic when virtualized. Yes? You've had trouble virtualizing a SQL server at some point, or a database server at some point? We're assuming. Or you have database servers that you want to virtualize but can't. Does that describe anybody? Is there somebody in this room that wants to virtualize a database server but feels they can't? One person? 2, 3? Don't be bashful. So we got a handful of people here. All right. Hopefully we can help you with that. If by the end of this session you still feel that way, come talk to us. Because this man can virtualize anything. Trust me. You have database servers you're afraid to virtualize, or you just know that DBAs are scary when they're mad. If one of these things, no, I'm not scary. I'm angry when I'm mad. So if one of these things describes you, then you are in the right room. So this is a little screenshot. This is some work that David had done. What was that? 144 virtual processors. Hey, does this have it does have a laser pointer. So 144 vCPUs. And honestly, David, I got a few here that weren't 100%. If you're not going to try to stress this system, just don't bother, you know?
Hey, Frogger can only do so much, man.
Frogger? Was that it? Frogger? All right. So that's a pretty good workload. Do you want to talk a little bit about it?
Yeah, these particular environments, this is what I call a monster server. This is one that, if you saw this, would you want to virtualize this? I say yeah.
I say virtualize anything.
I say
sure.
virtualize
Take it on.
anything and everything. And this VM could have gone bigger. This was a synthetic test that we did, but their average workload was in the 60 to 70% busy range on this kind of equipment day in and day out. And we virtualized it, and it worked beautifully.
All right.
You have to be careful, but you can do it.
So a little bit about you, David?
Yeah, a little bit about me. I'm David Klee. I'm a certified nerd.
Yeah.
I started my own company 4 years ago so that I can really focus on how data and infrastructure work together, and sometimes they complement, sometimes they contradict. I'm lucky enough to be both a VMware vExpert and a Microsoft Data Platform MVP. So I have a lot of fun. You know, I know where a lot of these companies are going. I see a lot of their strategies, and we can figure out how to make one silo work the best with the other. My contact info is up on the screen there. Yeah, a little bit about us. This is what we do. You're getting a lot of the tips and tricks that people normally pay for free here, and we're happy to do it.
So a little bit about me. My name's Tom, and I've been doing this for a while. I don't say I'm old, I say I'm experienced, right? There's a good difference there. I do enjoy working with data, probably too much to be healthy, really. I'm also a Microsoft Data Platform MVP, a VMware vExpert. I'm also a Microsoft Certified Master. I sometimes tweet and blog. I work for SolarWinds. Any SolarWinds customers in here?
Go back one.
What? Hold on. I want to know about my customers. Any SolarWinds customers in here, yeah? Yay. Come talk to me after. You're my favorites right now. So then you know all the stuff that we do. If you don't, come see me at the SolarWinds booth. I'd love to talk to you more. You want me to go back?
Yeah,
Why?
go back one. You see that Certified Master thing up there? There's only 200 in the world, and there's only 70 outside of the Microsoft Corporation. So that's the equivalent of VCDX. When you see this guy, respect him for that.
I just spent a lot of time learning a lot about one thing. The data platform is much bigger. I'm more proud about being a Microsoft Data Platform MVP than MCM. So. All right, the agenda. We're going to talk about database performance basics. We're going to go through some solution techniques, and then we will take questions at the end. And let's get started. So, as the DBAs and architects and most of the people in the room, and even the few managers that are here, you probably understand that there's only 4 possible resource bottlenecks, right? And we're talking, and I don't care if you're running Linux, Unix, or Windows, and if you're running Microsoft SQL Server, Oracle, or the Artist formerly known as Sybase. None of that matters. You're always going to be bound by CPU, memory, disk, and network. If you want to say locking and blocking, sure, we can talk about those as well. But those are the only possible resource bottlenecks. All virtualization does is turn hardware into a queue, right? That's all that's really doing for you. So when you think about when it comes to trying to analyze and do performance tuning for a virtualized database server, it's really not any different than what you're doing right now. All the information you need is still there. It's just in different corners of your environment for you to go collect, analyze, and figure out what to do next. Bad code and design will bring even the best hardware to its knees. True? Yes?
Yes.
We all know that, right? And yet, one of the first things we want to do in order to make performance better is what will we do? We'll throw hardware at it, right? How many people in this room right now, the first thing, if you're a VM admin, don't be bashful to admit this, but if a guest is having a problem, you'll throw a couple of extra vCPUs at it and hope the problem goes away. Yes? Raise your hand. Don't you lie to me.
You, sir, right
You
there.
do that, right? You've just thrown hardware at the problem. And if it works, it's great. And if it doesn't, now you got to do some more work, right? But the truth is, a few lines of code can bring even the biggest server to its knees quickly. So what you get is you understand that the result of this, it's just time and money wasted because you're just postponing the problem until you really analyze what's happening, right? As a VM admin, of course, your goal is to make sure people know that the virtualized infrastructure is not the bottleneck. You really want to be able to shift it to a piece of code. And it's not shifting for blame. It's just to understand, hey, look, how this has been coded, how this is working, can only scale and go so far so fast, like a ship. Like the Enterprise, it can only go so far so fast before the thing falls apart or Riker runs it into the ground, right? That's always what happens. So database is kind of the same way, and you have to understand that and think about it. It's not about blaming somebody or a piece of code, it's about just understanding what you've built can only go so far so fast, and we're going to have to do something a little bit different in order to make it perform better. That's just
Yeah. By the way, I want to shake up everybody's world here. Did you know SQL Server is about to be released for the Linux platform?
I knew. How many people are excited by that? Seriously. You're excited for SQL Server on Linux?
That's great.
That is good.
That's cool. Yeah. It's a lot of fun. It's coming. It's here. There's a lot of good, compelling reasons for it. There's also compelling reasons not to go to it. It all depends on your environment and what you're doing with it. But just wanted to let you know it's here.
Oh, is this me? I'm sorry, that was fast. Oh, so virtualized database server, yeah, we can do this. Don't believe the FUD. FUD is fear, uncertainty, and doubt that a lot of people will do to you like they did to David. You can't virtualize that. Wrong. Don't you know you're not supposed to be able to do that? Because I've been telling people you can't do that, so you can't go and do those things, because then that makes me look like I don't know what I'm talking about. Yeah, you can virtualize it. All the people who raise their hands thinking there's something I can't do, no, you can do it. So why is your database the resource bottleneck? Here's why. So the historical reason for virtualization, the first round of virtualization way back, if you're experienced enough to remember these days, did you virtualize for performance or for consolidation? Consolidation. Everybody in the room. There's not one of you in here said, I'm virtualizing this thing to make it run faster. You wanted to consolidate, or you wanted the HADR options that virtualization gave you, right? You didn't do it for performance reasons. Trust me, because I used some of those servers you built, and they didn't perform at all. So what that meant is that this became that, which was great. You reduced the price per square foot in your data center, and everybody was really, really happy, except for the people that needed performance. So what basically become the biggest SQL Server infrastructure pain points in the virtualized environment, right? So your over allocation of CPU and memory, storage latency. Why do we have vCPU up there? Oh, configuration for vCPUs, networking. These all become your pain points, but they're really your solution points. All right? You don't have to think of it necessarily as something that's going to be a pain, but just think about if I want to architect something a little bit better, these are the solution points that I'm going to focus on. So techniques, solution techniques that we're going to go over today. We're going to walk through each one of these bottlenecks. So we're going to talk about how to validate storage latency. We're going to talk about building a VM, right-sizing it, vCPU and VRAM right-sizing, disk configurations, and we're going to talk a little bit about network as well as some performance metric collection. So let's get started with some storage latency. I think it's you. Yeah.
Well, just want to say, when it comes to storage, every one of the vendors out here, or most of them, they're going to say IOPS, IOPS, IOPS. It's kind of like saying I've got a brand new Ferrari in the driveway and I go every single day and go hit top speed. I wish that were the case, because that's really fun. But realistically, what matters is when you're at a stoplight and the light turns green and you floor it so that you can get to the other lane and merge onto wherever you want to go. Transactional latency from a database engine, the speed it takes to take the database data that changes, commit it to disk, and get back. When it comes to database platforms, this is what matters the most. So I don't care about IOPS. It just has to be faster than what you need. But the round trip to disk and back has to be the lowest possible, 100% of the time, to get the most performance out of this. So one, you need to validate that your storage is actually capable of sustaining this sort of writes and these kind of reads, and do it as fast as possible. Maximum IOPS, it's important, but it's just less critical. The other big thing that I want to stress here, if you're not doing active multipathing right now with whatever storage array you're on, think about going into the command line and setting round robin IOPS equals 1. What it does is by default VMware says I'm going to pick a path and I'm going to send all VM traffic on this host down that path until my cumulative IOPS exceed 1,000, and then I'll pick another path. If you do round robin's IOPS equals 1, it just says, okay, give me all available paths, go, 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 go. And you're going to get a performance improvement, you're going to get lower latency to disk. You need to make sure your environment's set up for it and that your vendor, your array vendor, actually supports it. But just about all of them do, and just about all of them endorse this in their documentation. Hardly anybody sets this up. You need to go do it. VMware is actually starting to change. They're actually starting to make this the default now as of 6.0 or 6.5. With 6.5 Update 1, they actually set the pure PSP default to round robin IOPS equals 1. It's very great that they're doing this. Now, VM construction. We've got demos galore all over the place. We've got tons of examples. A click-through default of a VM for a database server is about as poor as it can get. Just like a click-through default install for a database server is not good. It comes up with all sorts of defaults that slow the performance down, slow scalability. I have to make sure that VNUMA is as solid as possible, and I'll explain this in a little bit. Paravirtual SCSI drivers, critically important. And to make sure that we use VMXNet 3, arguably a lot easier to go correct and deal with, and usually that's the case, but we still got to go check for it.
Yeah, so vCPU sizing. So CPU allocations. We already mentioned, and we already had people admit to it, that this is often the first thing you do when you're trying to performance tune, especially a database server. I'll throw some extra CPUs at it. So there's a concept, two big concepts that you need to understand if you're not familiar with. One is VM ready time, and the other one is co-stop time. So the VM ready time is similar to the runnable queue for a database server. That just means that I'm available to run and I'm waiting for a scheduler to get time on. Co-stop is essentially has to do with VNUMA and the ability to keep things in sync between NUMA nodes. Entitlement versus demand, we have a slide on in a little bit. The the point I'd like to make here is it's often the first step in performance tuning, but the thing you have to understand is if you're going to throw vCPU at a database server as your first step, two things I want you to understand. One, you could be making things horribly worse, especially if you're going over into a new NUMA node, right? You want to keep things on one NUMA node if possible. We're going to talk about that in a second. So one, you could really be hurting yourself by just throwing extra vCPU at it. And two, you only want to throw vCPU at it if you know you're having CPU pressure. And one of the easiest ways to look at that is something called signal weights percent. This is simply the database engine saying a percentage of my queries were waiting for an available processor. If you know that your queries are waiting for an available processor, then yeah, maybe giving it an extra processor would be a logical next step in performance tuning.
Cool. Yeah. Okay. See the chart right here? This is an example of a SQL server that just wasn't built right. This is also an example of a DBA that downloaded the SQL Server installer from the wrong place.
Yeah, there's only 20 CPUs out of 24.
Yeah.
Oh, okay.
There are SQL Server licensing limitations depending on how you install this and what you do. This one, for example, in the error log inside SQL Server, it said, we're sorry, we're only going to use the first 20 CPUs that you have.
But I gave it 24.
I gave it 24. Why isn't it using it? We don't know. The first step that we have to worry about here is how many CPUs are we going to give this. Because if we don't, if they're way oversized or if they're wrongly sized with what the physical infrastructure is going to give you, you get problems. And we're going to describe this in depth now. Now, from a business critical database server standpoint, the single biggest problem that I see in the field, and I see a lot of this stuff, is with how long it takes for a virtual machine CPU request to actually make it through the hypervisor and get to the physical CPU. The bigger the VM, the more activity on the host, all of these things get in the way of this stuff. The best part about this, though, VMware actually gives you the counters to see this. How many of you have heard of CPU ready time before?
I have.
Fantastic. Every year that I ask this question, more and more people raise their hands. That makes me so happy. But now, you've heard of it. How many of you go sample this stuff?
I do.
And for those of you that sample it, when was the last time you looked at it?
This morning.
It's a challenge. It's the single biggest problem that I see all over the place. And if you're sampling it, if you're interpreting it correctly, thank you. Thank you, thank you. If you haven't seen this, though, we really need to do a deep dive on it. What this is, it's a measurement of the number of milliseconds spent in the scheduling queue inside the hypervisor per virtual CPU per VM every 20 seconds. And what you end up with here is, if you go to the real-time view, you end up with the latest number right here. Now you have a really big number with the machine name next to it. That's just a sum of all the other numbers. So generally speaking, I'd just kind of throw it out for the real-time view. And then you have the maximum list right here, and that's the highest that number ever achieved in the last hour. So in this case, we can turn around and actually do some math. If you go to my home blog, there's one of the favorite posts on there, and I'm not creative with my blog post titles at all. It's called CPU Overcommitment and Its Impact on Virtual SQL Servers. I need a catchier title.
Yeah, that's good for SEO.
Yeah, but what it gives you is the ability to calculate what kind of percentage I can actually get of a performance hit on here. So essentially what we do is we take the biggest number that we've got up here, so let's say 56. That looks like a lot, right? Well, let's take 56, divide it by 20,000 milliseconds in that polling interval, 20 seconds, multiply it times 100%. And what you're going to find is, on average, that is well below 1/4%. That's nothing. That's perfectly acceptable from a production SQL Server workload. Everything is great. And what that means is you can pile more stuff on that physical machine, more VM traffic. And chances are, if you do this right, you're going to run out of RAM on the physical machine before these ever approach values where you need to actually be concerned with it. It's very fantastic, because what that means is, if we do this right, if we manage all this stuff right, my SQL Server licensing cost can either stay the same or can actually go down. I mean, you know VMware cost for this stuff. You know the cost of the hardware. From a database server perspective, SQL Server is upwards of $100,000 to license for one physical machine. And you don't even want to get started with Oracle. They're a lot higher. So if you look at it that way, if I can consolidate this stuff properly by monitoring this one metric, I can do more with that piece of physical equipment, which means I keep my licensing costs down. So your CIO is happy, your DBAs are happy, your app owners are happy, and now you've just made your CFO happy. Life is good.
Yeah, life is good.
Yeah. Now there's another one on here. The bigger the VM, the more we have to worry about something called co-stop. Nobody ever sees this. This is actually not even in the vCenter database. This is available in the real-time view only unless you change the vCenter statistics collection interval. What this is now we have a whole bunch of CPUs on a VM. We have an individual CPU scheduler per vCPU. These don't necessarily always have to be at exactly the same time. VMware has been relaxing this restriction for years. So what you get is the possibility for one vCPU to just run a whole lot faster than the others. And you can actually cause problems inside the operating system from things being too far out of sync. So VMware detects this, and they realize that, yeah, we need to slow some of them down. So what this is a measurement of exactly per millisecond, per vCPU, how many milliseconds it's actually stopped some of the CPUs to let the others catch up and resynchronize. It's fantastic, and nobody ever sees this stuff. If you have just normal ripples in here, no problem. No problem whatsoever. This is perfectly normal. And the bigger the VM, the more of these you're going to have. But if you start seeing sustained values or really, really tall spikes in here, what this can actually do is make it where the VM will basically go unresponsive for 5, 10, 30 seconds at a time. That's enough to start causing problems with your application. And that's when you really need to say, stop. We have to go evaluate where we're at. And this is right sizing, this is too many CPUs, or just plain too much activity on the host. Now here's the last one. This is an early indicator of problems. It's called demand versus entitlement. Demand is if there were no CPU scheduling pressure whatsoever, and if they had all the CPUs in the world, this is how many megahertz at that exact moment in time that virtual machine would consume. What entitlement is given the amount of activity on the host, this is how many megahertz are available to that virtual machine to actually consume. So essentially, this is very aggressive. But when demand goes well over entitlement, what you end up with is a performance bottleneck. And they may not see this directly, but the higher that goes and the longer it stays like that, you may end up with query disconnects or mission-critical processes running very, very slow that may result in the application throwing errors. So this is your early indicator. If demand is well below entitlement, life is good. But the closer it gets, and you need to be monitoring this, the closer it gets, you can actually learn and predict to say, we will be having problems here in a month. And now you can start to get in front of this.
I think the next couple are me.
Okay, cool.
Yeah. Just real briefly. So what's the right amount of vCPU and VRAM? And there's really two schools of thought. In the physical world, which I don't know if we're mostly used to that. I don't know how experienced they are. What I've been used to in the physical world is you always think about things in terms of end of life. This will be about 30 terabytes in size. Well, I'll go buy 30 terabytes of disk and storage for that. But we're not using it yet, but that's okay. We're going to get there someday. But in the virtual world, you only have to size things for what you're using right now, right? So idle, one thing to consider, like if you're going to ask for a virtualized server and say, give me 8 vCPUs to it, there's a few things to consider. But one you want to understand is that idle vCPUs can harm VMware performance, right? You don't want to assign a vCPU and just have it sit there and be idle. And you want to profile your workload resource consumption with your DBAs. Basically, you want to know exactly what they're using. So back in the day, when I started virtualizing things, it went like this. I had a, say, 8-core box, and it was about 10% utilized. And when we tried to virtualize it, the infrastructure team said, well, I can't give you 8 vCPUs because it was vSphere 3.1. So it only went 2 CPUs. And they told me, so we can't virtualize this thing at all. Now, meanwhile, I have friends who are virtualizing workloads left and right, I'm pretty sure. Well, the easiest thing for me to do is look at the formula. The hardware they were giving me for those CPUs, if I did the math, the megahertz, right? 8 times whatever I had was less than 2 times what the new CPUs gave me. So I was like, I was pretty sure the speed was going to be enough for those 2. So I just need it for now. And I was only using 10% of the 8 I was given anyway, because back in the day, that was what you wanted. So when you thought about all that and you think, you know what, all I need right now are just the 2, and we'll go from there. So I had to profile all my workloads and really you couldn't just look at the hardware specs. I had to look at what my SQL Server workloads were actually using on that hardware. And then I had to, because it was a lengthy process, I said, all right, this is where I'm at today, this week, this month, and I have to repeat that process over and over. What was this? There's a blank slide.
Yeah. No, it's fine. Lead into that.
Oh, yeah.
Yeah.
Oh, this is you.
This is an actual perfmon trace graphed. And what this gave me, this was a month worth of activity on this machine, extrapolated out to give me a baseline for what this machine was supposed to be doing around the clock at any given point in time. And this is by virtual CPU. This machine had 8 CPUs on there. Now, we were looking at licensing, we were looking at performance impacts of, just having all this stuff on the physical machines. And we looked, and at peak, on a single CPU, we were just approaching 50%. Now, if you take a look at this, that was a database backup operation, single-threaded. What's the right sizing on here? How many CPUs should this thing be given? 4. Somebody called it over there. That's exactly it.
2. You said 2.
2's a little tight. I want to have a little bit of headroom in there for normal day-to-day operations. So if we went to 2, this whole window of business critical activity right here would be approaching 100%. And that's a little too hot. So you could probably get away with 3, but you would have not a lot of room to grow. So if you go to 4, that gives you plenty of headroom, but you're running this a lot tighter. So we went to 4, and we actually got a slight performance improvement because there was less that this thing had to go schedule onto the hypervisor and less CPUs for both Windows and the database engine to have to juggle and sort around.
Yeah, so the question, do they need all 8? Nope.
Yeah. Okay. So now, let's say we've gone through our exercise, we've looked at all the performance data, and we figured out that we need, let's say, 8 CPUs for this given SQL server. Now, that's not everything that we need to accommodate here. What if that 8 CPU does not fit comfortably inside one CPU socket on the physical machine? If this is the case, then it can spill over and you can have cross-NUMA node memory lookups that are arguably a lot slower than if they were on the same NUMA node. So ideally, if the VM will fit inside one of your CPU sockets, size the thing to fit in there, and that includes memory as well. Now, an example of this, let's say my physical machine is a 2-socket by 12-core physical machine, and the virtual machine that I need to create needs 10 cores. 10 fits inside 12 very comfortably, and I'm going to build this virtual machine with a 1-socket by 10-core VM. And that fits there very well, And the virtual layer is actually going to do a very good job and try to keep all the memory right there. It's going to set a NUMA home affinity, and life is good. But now, what if I need a 16-core VM? Well, 16 does not fit comfortably inside of 12. So let's take that 16, let's cut it in half, and let's build a 2-socket where each socket has 8-core virtual machine. That fits comfortably inside each one of those NUMA nodes. And the hypervisor itself is going to turn around and balance it properly. It's going to perform faster. And what you're going to find through objective database benchmarking is that this configuration versus the other is probably going to be quicker. And again, work with your database administrators to actually go validate this, because you may end up with some unexpected results here. But this is where you should start. And it's not just the virtual layer that you have to worry about. Excuse me. Windows does its own NUMA management. The database server does its own NUMA management. Individual queries can actually be moved from NUMA node to NUMA node, all within the database engine. You have to be very careful with this, and this is why I say start here, do your testing. Now, the database administrators are watching your every move. They can actually see from the database engine itself what you have given it. For example, it's very simple. You open up SQL Server Management Studio, you pick the database server, you hit right-click Properties, go to CPU. They can see right here very easily what NUMA node information is actually getting presented to them. So if you haven't done your job in a way where they've asked you, they can see it. And DBAs are angry when they get mad. Now, here's why we have to really be careful with the performance. Not all these configurations are created equal. So let's say I have a 16-core VM. I know I need all 16 cores for this database engine. Well, what's the right way to build this? Do I do a 2-socket by 8-core VM? Do I do a 4x4? Do I do an 8x2 or a 1x16 or a 16 by 1? Anybody, what's the next comment or question I should ask? Yeah, you got it right there. The question you should ask, what does the host look like? Thank you, good call. In this case, this particular host is a 4-socket by 10-core host. Okay. Now what do? We're going to assume the 4x4 should win out here, correct? Test it. Very simple. Test it under varying degrees of workload intensity. This particular chart was run with the HammerDB database benchmark. It's free. It works on SQL Server, Oracle, MySQL, Maria, and Postgres databases. It's wonderful. And what you're going to find is that not all database workloads respond the same given the virtual NUMA configuration. This one in particular, the 4x4 came out on top until we hit this number of database users. And then what we found was, as the workload ramped up, the database engine and Windows and VMware and the physical machine started to become more efficient at accommodating the really high volumes of traffic on 2 NUMA nodes instead of 4. So the 4x4 started to top out, whereas the 2x8 continued going. So this is why not only do you have to do a right sizing evaluation now, but you need to do this every quarter. Because as data gets added, users get added, reports get added, people use this stuff more and more. And let me tell you, managers with Excel, they're going to crush this stuff. These workload characteristics change. So you have to continue to watch this and monitor it. Now, how many of you have virtual CPU hot add enabled? Don't. Every single person that raised your hand, go back to the office, don't go to the party tonight, remote in, and turn it off.
Well, I mean, they might need it.
You might need it.
You should ask them first why they chose that.
No.
No, all right.
If you have 1 or 2 or 3 CPUs, you know, it doesn't really matter at that point if you need a couple more. Realistically, if I have these big monster VMs that I'm worried about, if you turn that on, it does not matter what you do right here with cores per socket, a number of sockets, it will not extend it. And you can see that right there. You get 1 NUMA node, and now you have a memory imbalance, you have a CPU scheduling imbalance, and it will cause a performance problem for these bigger machines. If the VM fits comfortably inside of 1 NUMA node, your mileage may vary. Now, one last thing. How many of you have upgraded to vSphere 6.5 yet? All of you? Come on,
yeah.
come on.
A good number.
Yeah. 6.5 is great. It's a wonderful release. Update 1 is out. The HTML5 client works really well, but there's a gotcha. Remember how VMware used to say, assign, let's say, 16 sockets by one core and they would automatically manage VNUMA for you? Mm-hmm. Doesn't work anymore. And in fact, this entire drop-down right here doesn't matter anymore. They assign virtual machine NUMA based on what the physical machine looks like. Doesn't matter what you set that to. And in most cases, they get it right. But you saw from the chart before, they get it wrong in some cases because a 4-socket machine and a 4-socket VM may not always perform the best based on your demands. So what you need to do is to be aware that this no longer applies, especially if you have mixed hardware where the CPUs are different and the core count is different. Because us data geeks are actually going and assigning parallelism settings inside the database engine that's dependent on this. So you need to watch out for that, right there. Yeah, right there. 1 socket by 16 core, I got a 2 by 8. Be careful with those. Most of the time they get it right, but when they don't, it's not good. Okay. Yep, actually just talked to that. Mm-hmm. Yeah, okay.
No, go back.
There we go.
There you go.
Yeah, no, we talked to it.
VMware recommends. Oh,
yes.
Yeah, we did all these?
Yeah, we did all of these. Now,
all right then.
Memory. How many of you are over-committing the host that your database servers are running on?
Oh, admit it. I'll admit it. I did it. Of course, I was testing to see what would happen.
Smack.
Yeah. Oh, yeah. So memory allocations. Where are we here?
Yeah, just reserve all guest memory. Don't
don't
overcommit RAM, please.
Yeah, don't reserve all guest memory. So here's the thing.
Do.
Oh, do? I'm sorry.
Do reserve all guest memory. Don't overcommit RAM.
I wanted to say don't overcommit, over allocation. So the idea is really simple. Is virtualization allows you to be very easily to over allocate, right? Which we all think is a good thing. But when it comes to database memory, you don't really want to get into a situation where your database server tries to get memory that isn't there anymore, right? Has anybody had a VM, a guest or a host just kind of blue screen because there was memory reservation set that actually turned out to be more than what the host actually had? That's a fun day, right? I can't get this thing to boot up. Why is it? Oh my God, all of that adds up to way more than what I actually have in there. So things to think about when it comes to setting the memory for your SQL Server. So no host memory overcommit at all. So I'm going to tell you that whatever you have for your host, only commit about 80% of whatever you have installed. So whoever's might be telling you, no, you can allocate 1 or 1.5x, whatever, don't listen to them, 80%. All right, there's 2 reasons why. 1, I just told you, database servers, I'm very protective when it comes to this. Can you think of another reason why you'd only do about 80% of what you have?
Hypervisor needs memory too.
Hypervisor needs memory too.
Exactly. And there's overhead for the guest memory.
Overhead for the guest. How about if I have to fail something over? How about if I have to move a machine from here to there? Wouldn't it be nice if I had some overhead for growth and failovers, right?
Yeah.
So 80% of memory, 80% of CPUs as well is what I usually tell people. Yeah. Just think about some overhead in case you have to move stuff around. Once you hit 80% of whatever resource you have, once you hit 80% of that allocation, think twice about what you add next from there.
A favorite little engineering phrase, host failure cluster tolerates, because that rolls right off the tongue.
So reserve the guest memory at the VM level because this will shrink the guest swap file. This is one from David. You have a nice little tip here about the blank file.
Yeah, essentially, if you're not overcommitting RAM at all, I still want to reserve all guest memory here for the mission critical production SQL servers. Because what this does, it actually retains a swap file on the VMFS file system just in case it needs to start swapping. Well, in this case, if you check the reserve guest, all guest memory checkbox, that file drops to 0 bytes. Now, if you're not on a data reducing array, you just freed up that amount of space on your SAN. That's cool. That's really cool.
So VMware has this little thing here, this nice little statement. Use the active memory counter from vSphere with caution. That's nice. That's VMware telling you to pay attention that vSphere might be lying to you. But vSphere is not really lying to you. What it's telling you is that active memory is the amount of memory that's currently used by the guest operating system and its applications. SQL Server does its own caching and memory management. I can't stress this enough. There's a SQL Server best practices guide, a PDF out there. You can check it out here. And there it is as well. The thing is basically it comes down to locked pages of memory. So vSphere is going and looking at the memory consumption for processes that's running on the database server, and it's reporting back an active memory counter, and it's adding things up for you, and it's got no knowledge of what SQL Server internally is actually doing inside of that guest. So use those counters with caution. Make sure you know where you're getting your metrics from. Because I know there's somebody in this room that has looked at it and said, hey, look, there's not a memory problem going on. All right? When actually there is, and there are ways for you to get that information. Disk I/O. So SQL Server is latency sensitive. What isn't, right? Everything's latency sensitive. I hate waiting for things. I'm sure you do too. So often legacy storage networks are in place. It's my experience that when it comes to how applications kind of move forward in the business and new servers come in and a new app is built and all this stuff, one of the last things that ever happens is somebody just rebuilds the SAN in order to stay up to date, right? That's kind of a hard thing to do in a day. It takes a little bit more than that. It's just like when they say, I need to upgrade the network. It's not something you can just flip a switch and, or build a new index and get better performance. So you have storage networks that are kind of been around for a little bit, a long time, and they haven't really been optimized for database performance. And if they get years and years old, you sort of find that they aren't anywhere near where they need to be for modern database workloads. And they usually are not optimized for virtualized workloads at all. So performance factors such as multipathing interconnects, controller cache amounts ratios, flash drives, one more, and raw disk pool speed. These are the things that you're going to want to focus on when it comes to your disk I/O. Storage maximums.
Yeah. Okay.
Yeah, you want to talk about disk speed.
Yeah, this one's fun. Okay, all of you, I want you to repeat after me. I promise.
I promise.
That I will not take what I learned today.
What?
And I will not do this in production.
Okay, I will not do this in production. You got me. All right.
Yeah. Fingers crossed. The challenge here is if you go and get storage, enterprise storage, doesn't matter how good, how bad, how cheap, how expensive, every single bit of performance that you have in there has a performance ceiling as it's presented to your virtual machines. Arguably, the database servers are amongst the most I/O hungry VMs that you've got. I need to go test what kind of performance that I can get at peak. And that way, if my tests are similar to a database workload, I know how much headroom that I have. And then if I start watching this and trending it, I can say, well, I may have 30 terabytes left on my storage array, but I may only have 10% of the performance remaining that this thing can actually deliver. Now again, this is not a substitute for database performance testing. I cannot stress that enough. But this is a good way to get an understanding of, given a set of parameters, what the array can actually do. Now, Microsoft has got a free utility out there called Disk Speed. It's a replacement for a tool called SQL I/O. It works great. We actually have a batch script here. It's just PowerShell and a spreadsheet. It's free. I don't ask for any contact info. Go check it out. But it will actually help you simulate a storage workload on whatever storage you're doing. So it gives you an idea of what this thing is actually capable of. Now, if you're on a data reducing array, things like that, your mileage may vary because these are very scripted workloads. But it gets you an idea. So take this. The thing that this is going to collect is going to be IOPS, latency, and throughput. IOPS, again, very important. Latency is even more important. I need to know how this thing is going to respond. Now, you take this, and what this test does is it actually iterates through different block sizes, different workload characteristics, and you pick the place where it goes and runs. And what you end up with is a profile of what the storage can actually do at a certain workload. And it's kind of fun because it breaks it up through random or sequential, read and write, and you end up with a footprint. And with that, you can kind of visually see, is there something going on here? Is something unusual? You can go see. It gives you that ceiling. And then you take this and compare it with steady state operations that you collect day in and day out with whatever monitoring tool you've got. and you can go see where we at. It's pretty cool. And I stress it again, not a replacement for a SQL Server workload. The only way to do this is with a database. Your DBAs have a utility that comes with SQL Server called Distributed Replay. They can capture a production workload and replay it against a test system. So it's not a similar test. It is your workload replayed against a test environment for you to do testing with. Cool. Now, the benchmarking layers, things get really interesting. When you do the monitoring while you're doing all this testing, most people track one counter here and then they go way over here and look at what the storage is reporting. You have to monitor all these different layers because I need to go actually monitor what the HBAs or NICs on the controllers are doing. I need to monitor switch port consumption. I need to monitor what the back of the physical machines are doing with those uplinks. I need to go monitor whatever delays are in there and if things are actually getting there properly.
Oh, can you go back?
Yeah.
I was just curious. Who here right now is monitoring end-to-end, from guest to disk pool, the controllers, everything in between? Anyone? Okay, like 3 people. Who here would like to monitor all those things? Way more. Come to the SolarWinds booth. All right.
Yeah. Now, another thing you need to monitor. How many of you are running Blade servers today? Probably most of you, yeah. Are you actively monitoring the ports that come back out of the Blade chassis?
Would you like to?
You need to. So, I mean, I have a bunch of VMs. Each VM has a virtual network adapter. Life is good. This is what we've been doing for years. I got a physical machine. I've got 2 10 gig network adapters coming out of it. Okay, well, I've got all of this in a Blade. So you know these network adapters coming out of the Blades are actually virtually created and presented from the physical Blade chassis. It gets real confusing. We got physical virtual devices. We got fake virtual stuff. It's tough to go gauge what it's actually doing. My question to folks whenever I go do consulting is, what are those doing? What are the network adapters on the Blade chassis itself actually doing? And in a lot of cases, they don't know. So what do we have to do? And in some cases, this causes problems. An example here, we had 4 virtual machines, 1 on each blade, because these are very big VMs. I needed to go figure out why we had extreme storage latency and why the storage team was saying everything was fine, the DBAs were saying everything was wrong. I mean, how many of you have been in that state before? Yeah. Now, one for you all. This meeting got so bad, 10 minutes into the first meeting, me as a consultant in the middle as a punching bag, mediator between the 2 sides, the storage person picked up a chair and threw it. He was that upset. Because he was right and the DBA was wrong.
Did he throw it at you?
No, he went over my head though.
Okay.
And the DBA was right and the storage admin was wrong.
Yeah.
So we believe in objectivity with this stuff, and that's why we're here. So give me the I/O footprint of the first virtual machine. We knew these were in a Blade chassis. We had no visibility into anything else, but we knew 1 VM per blade, 4 blades. That's the I/O footprint of the first VM. This was taken over a month. That was an average day. And this thing was a very hungry I/O consumer. So now take the second one, stack it. Take the third one, stack it. Now take the 4th one and stack it. This is what was actually going through the Blade chassis. Anybody see any patterns or anything unusual with this image? There are 2 things in here. One, that is what 2 8 gig fiber adapters on fast storage can actually deliver. And you notice that nice little flat line on there? But there's one more. That is no multipathing. That's 1 8 gig connection getting consumed by one of them, and the others were forced to make do with what was left. So we had 2 challenges. We were able to go prove now that we were bottlenecking on 2 8 gig fiber adapters coming out of the Blade chassis, even though each individual VM looked like they had plenty of headroom. Now let's take this, and let's take the database storage latency as a database engine saw it, and let's overlay it with this. And this made a CIO lose a cup of very hot coffee through his nose when he saw this chart. And we'll just say there was a lot of yelling for about 2 minutes while he cleaned it up.
Was there another chair flying through the room?
No chair flying on this one, but everybody was in the room and they watched this guy make a fool out of himself because I've got a really bad sense of timing with these things. But what we found was every single time that we were bottlenecking the HBAs, the storage latency as experienced by SQL Server was very, very high. And it was so high that SQL Server was throwing alerts that said, hey, this I/O took longer than 15 seconds to complete.
Yeah.
That's the average latency. So we correlated it. And 9 months of arguing at this customer boiled down to this one chart. And the storage gentleman in the back of the room finally went, oh yeah, sorry about that. Yeah, it's an 8-port card. We'll just cable up the rest. This stuff is real.
It's a happy ending, though. All right? So performance metric collection. If you're not collecting metrics, you're doing it wrong. So you need to be collecting metrics. If nothing else, when somebody calls and says the system is slow, you want to be able to know just how fast it's supposed to be. Usually when I ask that question, how fast should it be, somebody says, I don't know, it should just be faster. Baselining lets me tell them how fast it has been over time. So you have to be able to get insight everywhere inside your system. So the storage team, the server team, the DBA teams, you all have your own kind of metrics and counters. And you all think they might be equal, but they're not. Like a SAN counters or storage counters a lot of times are aggregates over a minute, and it's an average type thing. And some of the stuff in SQL Server is down to the second level of detail, right? And it goes back and forth. So every now and then you think counters are trying to show you the same thing, but they may not be measuring things in the exact same way. But you've got to be able to answer certain questions about what's going on in your environment. One of my favorite things is when you get asked to stagger your database backups because you're flooding the cache or the array or something. Can you just like maybe not do them every night, maybe do them every other night or something like that? And you're looking at them going, no, database backups are important. We're going to have to do these. And the business needs them done at certain times of the day. But you have to work and understand, maybe their backups are actually causing problems because you have some shared storage somewhere else and it's a noisy neighbor for somebody else. Or maybe you're trying to run some sort of batch job at night and you're being the victim of a noisy neighbor somewhere else. If you don't have insight into what's happening elsewhere in your environment, you're kind of going to have trouble figuring out what the real root cause is. Access to vCenter for everybody is important. So usually the DBAs, is there a DBA in here that does not have access to vCenter? One, none? Everybody has access? Yay. Because that's always historically been a problem. You only need read-only access. No DBA in here is looking to vMotion things around on you. We just want access to the metrics that vSphere has. That's it. We just need to be able to see them so we can help our customers understand what's going on in the environment.
Yep. And for those of you that didn't perk up there, please give them read-only access, because if you don't, I'll give them the queries to go to the database directly and get it anyway.
Yeah, I was told I couldn't get it. You weren't getting access to vCenter, vSphere. You just weren't going to get it. And I said, all right, so you guys know it's a SQL Server database that vCenter runs on, right? And I'm smart enough to run a couple of queries and build some views and get all the information I need. And I did that for like 2 or 3 weeks. I was building all this stuff, but it was a real pain. And then I finally just realized, all right, here's what we're going to do. First, I got them to admit that if I had to research a performance problem, it was important for me to research the virtual layers, and I'd have to go to the server team for the information. They all agreed to that. I said, great. So here's what we're going to do. And I picked the meanest manager in the company. And I said, the next time he calls, I'm going to remind him that he has to call you first to make sure that it's not a problem in the virtual layer before he calls me. The next day, I got my login to vCenter. So all layers matter, as David showed you. That was a brilliant example that he gives you of the HBAs and looking at it and understanding the layers between what the storage metrics have and what SQL Server and a couple of lines. I told you, we're the managers. I told you we had pictures for you, right? I did not lie. Did that picture? That was good. Didn't disappoint, right? A manager, you understood that. Right, perfect. So you have to be able to put these together, overlay them, look at them, and see the bigger picture of what's happening in your environment. All right, so let's wrap it up here. We got less than 10 minutes, I think. All right, tips and tricks. First thing, don't run everything at once. If you can avoid it, don't run everything at once. This is true for a lot of different types of workloads, but if you can stagger things and use your resources wisely, you should try to do that. Sometimes it's unavoidable, I get that. But if you know that one system tends to run, so most of my background is financial services. That means we had stuff that opened at the beginning of the day, stuff done in the middle of the day, and then you close your books at the end of the day, right? And it's just a cycle and it goes from there. That meant I could figure out which applications were in use at different times of the day, and I could try to size things appropriately. The other thing, baseline and benchmark for performance, because if you don't do that, you can never really help somebody solve a problem. If you don't know what performance is supposed to look like, if you don't know what good is, you don't know what bad is.
Exactly.
Be mindful of thin provisioning. So we've updated this slide. I used to just tell you don't use thin provisioning ever. I've softened my stance on that, mostly because David told me I was being unreasonable, and I listened to him. So to me, historically, thin provisioning is a problem because you're allocating space, you're writing checks that it will have to be cached at some point, right? So if you're using thin provisioning, you're basically saying, hey, I need 40 gigs, but I don't need it all at once, right? That's thin provisioning. However, every time you grow that file a little bit, then fragmentation occurs, right? Little by little, and as a DBA, I hate fragmentation. The other problem is you don't know if you have all these growth events if you'd run out of space on that disk, right? So that's a problem too. So these days, we tend to say, all right, here's the deal. If you are using thin provisioning and you have flash storage, then fragmentation no longer matters as much. Okay? So that's fair. So I've softened my stance.
Yeah, just
so now I tell people that if you are using thin provisioning, be mindful of all of that you've allocated or promised, because if you don't want to get caught in the point where the VM can't grow because it's out of space. So if you have tools in place that are doing that for you, great. If not, you should be actively doing that. Otherwise, just don't use thin provisioning, to be honest. I'm not a fan. I like, as I said, I'm a database guy. I like to have all the space I can get right when I need it and keep things as contiguous as I can. All right. Performance and data store options. So back in the day, RDM versus VMDK, there were a handful of differences. Almost all of those differences are gone now. I can't think of one technical reason for you to say VMDK versus RDM anymore. It used to be size, used to be all these different things. The only thing these days where RDMs matter is if you want to do native SQL Server HA solutions like clustering. That is it. Other than that, if somebody says RDM better performance in VM, nope. RDM gives me 2 terabytes in VM, nope. All those things have gone. It's only if you want to use native SQL. Now remember, once you go RDMs though, you don't get the metrics and the details that you get with VMDK. So there's a trade-off for that as well. Avoid overallocation of CPU and memory. Just don't do it. If you can avoid it, yes, don't do it. And capacity planning. Again, you want to make sure that you leave room for growth and failovers. By the way, there is a book. It just came out a month ago.
A couple months ago.
VMware vSphere 6.5 Host Resources Deep Dive. If you haven't heard or seen this book yet, you have now, and you should go get one.
It's in the bookstore. Buy it. Read it twice. Give it to your colleagues. Force them to read it. I don't care what it takes. This is the definitive guide on CPU scheduling and memory management inside modern CPU architectures. And again, forget the fact that it says VMware. This is just an incredible CPU architecture book.
Yep. And that's it. So this is the agenda we promised. We go through database performance basics. We talk through some solution techniques. We would take questions at the end. It is the end. I want to say one thing before we sign off. Surveys. Please fill out the survey.
You don't know how critical this is to make sure, or to ensuring that you get database content at this conference. I know most people skip over the surveys. They really do matter. It means we get asked back. It means we get to contribute to really furthering the database messaging here to make sure that you're able to go get this stuff running as fast as possible.
So we've only got a couple minutes. I know lunch is waiting for probably a lot of you right now. So if you want to head out, go ahead. But if you have questions, Dave and I can stay here for a few minutes. Just come on up, ask us the questions. We'll hang out for a little bit, get them all answered. Otherwise, if you want to take off and go to lunch, do that. Okay. Thank you.